What if I told you that in 5 years, your doctor could watch you die before it ever happens? Not in real life. In a simulation. A perfect digital copy of your body, your heart, your lungs, your brain, down to the cellular level, running millions of scenarios to find the exact moment something goes wrong, and then stopping it before you ever feel a symptom. This isn't science fiction. This is called a digital twin. And right now, hospitals and tech companies around the world are racing to build one of you. But that's just the beginning. We're entering an era where AI doesn't just assist doctors, it sees things human eyes physically cannot see. Where surgeons operate with superhuman precision guided by machines that never blink, never fatigue, never forget. Where your body is monitored every second of every day by invisible sensors that know you're getting sick before you do. In this video, I'm going to show you the 3 technologies that are transforming medicine from reactive to predictive, from treating disease to preventing it entirely. And the third one? It might already be on your wrist right now. Let's dive in. For all of human history, medicine has worked backwards. You get sick, you notice symptoms, you go to a doctor, they run tests, they figure out what's wrong, they try to fix it. Sometimes they succeed, sometimes they don't. But here's the brutal reality of that system. Every year, over 400,000 Americans die from medical errors alone. That's the 3rd leading cause of death after heart disease and cancer. 1 in 5 diagnoses is wrong or delayed. And by the time most cancers are detected, they've often been growing silently for years. The problem isn't that doctors aren't smart. They're brilliant. The problem is that human beings, no matter how trained, are limited. Limited by what they can see, limited by what they can remember, limited by time, limited by the sheer complexity of the human body. Your body produces approximately 2 terabytes of data per day. Heart rhythms, hormone fluctuations, cellular changes, protein expressions. No human doctor could ever process that. No team of doctors could. But you know it can? A machine. We are witnessing the single biggest shift in medical history, from reactive medicine to predictive medicine, from treating symptoms to preventing them entirely, from one-size-fits-all to personalized down to your unique DNA. And it all starts with a digital version of you. Imagine this. You walk into your doctor's office, they pull up a screen, and on that screen is you. Not a photo, not an X-ray, a living, breathing, fully functional digital copy of your entire body. Your heart beats in sync with your real heart. Your blood flows through virtual arteries at the exact same pressure. Your cells divide at the same rate. Your organs respond to stimuli exactly as yours would. This is a digital twin. And here's what makes it revolutionary. Your doctor wants to try a new medication. Before giving it to you, they give it to your digital twin. They watch how your virtual body responds. Do your kidneys handle it? Does your heart rate change? Are there side effects specific to your biology? They run 1,000 simulations in seconds. Only when the digital version of you responds well do they prescribe it to the real you. No more trial and error with your actual body. No more, let's try this and see what happens. No more being a guinea pig for your own treatment. So how does this actually work? A digital twin is built from your data. We're talking your complete genome, all 3 billion base pairs of your DNA, your complete medical history going back decades, your current vital signs, blood markers, and organ function, your lifestyle factors, diet, exercise, sleep patterns, stress levels, even your microbiome, the trillions of bacteria living in your gut. All of this data feeds into an AI system that creates a computational model of your unique biology, a model that can simulate how your body will respond to virtually anything. And this isn't theoretical. In 2023, Siemens Healthcare launched their AI-powered digital twin platform for cardiac patients. Doctors can now simulate heart procedures on a virtual copy of a patient's actual heart before performing the real surgery. The results: procedure times cut in up to 40%, complications reduced significantly. Doctors can literally rehearse the surgery on your heart before they ever make an incision. But hearts are just the beginning. Dassault Systems, the company behind software used to design airplanes and cars, is now building full-body digital twins they call living heart and living brain projects. The goal? A complete virtual human that responds like a real human. For cancer patients, this is game-changing. Right now, oncologists often try multiple chemotherapy drugs to find what works. Each attempt takes weeks or months. The cancer keeps growing. The patient keeps suffering. But with a digital twin, you simulate dozens of drug combinations in hours. You find the optimal treatment for your specific tumor, your specific genetics, your specific body. Personalized cancer treatment, not based on averages, based on you. Philips Healthcare is already piloting digital twin technology in ICUs across Europe. They're creating virtual patients that mirror real patients in real time. When the digital twin shows signs of deterioration, nurses get an alert, sometimes 6 to 8 hours before the actual patient shows symptoms. By 2030, experts predict that digital twins could become a standard part of healthcare. You'd have a digital copy of yourself that ages alongside you, updated constantly with new data. Your annual physical? It's running on your twin 24/7. A potential drug interaction? Your twin catches it before you swallow the pill. A silent heart condition developing? Your twin feels the strain years before you do. Think about what this means. For your entire life, you've been the experiment. Every medication, every treatment, every medical decision, you were the test subject. Digital twins flip that completely. The experiment runs on the simulation. Only proven results ever reach your real body. But simulating treatments is only one piece of the puzzle, because even with perfect planning, surgery itself remains one of the most dangerous moments in medicine. Human hands shake, human eyes miss things, human concentration wavers. But what if we could fix that? The human hand trembles about 8 to 12 times per second. You don't notice it when you're drinking coffee, but when that hand is holding a scalpel inside someone's brain, those micro tremors can mean the difference between a successful surgery and permanent damage. Surgeons train for decades to minimize this. They develop incredible control, but they can never eliminate it entirely, because they're human. But what if they didn't have to? What if an AI system could analyze those micro movements in real time and compensate for them automatically? What if the machine could steady the hand, guide the cut, and see things the surgeon literally cannot see? This is AI-assisted surgery, and it's already here. You've probably heard of the Da Vinci surgical system. It's been around since 2000, and there are now over 7,000 of these robots in hospitals worldwide. But the next generation is something else entirely. The latest systems don't just follow a surgeon's commands, they actively assist. They provide real-time feedback. They see beyond human vision. Let me show you what I mean. A human surgeon looks at an organ and sees an organ, pink tissue, blood vessels, structure. An AI surgical system looks at the same organ and sees blood flow patterns indicating which vessels are compromised, thermal signatures showing metabolic activity, spectral imaging revealing cancerous cells invisible to the naked eye, tissue density variations measuring down to the millimeter. It then overlays all of this information directly onto the surgeon's field of view, like a heads-up display in a fighter jet, except for surgery. The surgeon sees exactly where to cut, what to avoid, and how deep to go in real time, updated thousands of times per second. In 2022, Johns Hopkins performed the first fully autonomous robotic surgery on soft tissue, a laparoscopic procedure on a pig. The robot handled the entire operation without human intervention. It outperformed human surgeons in precision and consistency. Now, we're not replacing surgeons. That's not the goal, at least not yet. The goal is augmentation. Imagine a surgeon making an incision and the AI immediately analyzing, is this cut optimal? Should it be 2 millimeters to the left? Is the pressure correct? Based on 10 million previous surgeries, what's the ideal next move? This feedback happens in milliseconds. The surgeon sees a gentle guidance indicator. They adjust. The result is superhuman precision, powered by human judgment. The numbers are staggering. Studies show AI-assisted procedures can reduce complications by up to 50%. Surgery time decreases, blood loss decreases, recovery time decreases. And here's the most incredible part. Every single AI-assisted surgery teaches the system. Every cut, every stitch, every outcome fed back into the machine learning model. The AI doesn't just maintain its skill level, it improves constantly. It learns from every surgery happening simultaneously across the world. A surgeon might perform 500 similar procedures in a career. The AI has already analyzed 5 million. Companies like Medtronic, Johnson & Johnson, and Intuitive Surgical are racing to develop the next generation of these systems. Verbal Surgical, a partnership between Verily, Google's life science arm, and Johnson & Johnson, is building operating rooms where every instrument is connected, every data point analyzed, every decision supported by AI. And this opens another incredible possibility: remote surgery. A trauma victim in rural Alaska, the nearest surgeon with the right specialty is in Seattle, 1,000 miles away. With AI-assisted robotic surgery and 5G connectivity, that Seattle surgeon could operate in real time, with the AI compensating for any network latency, ensuring movements are precise despite the distance. World-class surgical expertise available anywhere on Earth. A child in a developing nation could receive surgery from the best specialist on the planet. Now, I want to be clear about the current reality. Fully autonomous surgery on humans is still years away for most procedures. Regulatory approval moves carefully, and it should. The stakes are too high for rushing. But AI-assisted surgery, where humans remain in control with AI support, is expanding rapidly. Every month, new capabilities are approved, new hospitals adopt the technology, new procedures become possible. By 2030, it's projected that the majority of complex surgeries in developed nations will involve some form of AI assistance. The surgeon of the future doesn't compete with AI, they merge with it. Human intuition and experience amplified by machine precision and analysis. But here's the thing about both digital twins and surgical AI. They rely on data, massive amounts of data about your body. And traditionally, that data has been captured in snapshots, a blood test here, a vital reading there, moments in time. What if we could capture it constantly? What if your body was being monitored every second of every day? Let me ask you something. Right now, as you're watching this video, do you know your blood glucose level, your cortisol, your blood oxygen saturation, your heart rhythm variations? Of course you don't. Nobody does. Not continuously. You get snapshots, a blood test every year, a checkup that measures you for 15 minutes out of 500 and 2,500 minutes in that year. That's 0.000003% of your life being medically observed. The other 99.97%? You're on your own. Diseases develop, conditions worsen, warning signs pass unnoticed. Until they can't be ignored anymore. But what if that changed? What if your body was being monitored 24/7, 365 days a year? What if an AI was watching every heartbeat, every fluctuation, every subtle change, looking for patterns that predict problems before they become problems? This future is already beginning. Look at what's on the market right now. Apple Watch detects irregular heart rhythms and has literally saved lives by alerting people to atrial fibrillation they didn't know they had. Continuous glucose monitors from Dexcom and Abbott let diabetics track blood sugar in real time without finger pricks. Oura Ring tracks sleep stages, body temperature, and heart rate variability while you're unconscious. These are consumer devices, available today, already collecting more health data than most people have gathered in their entire lives. But they're just version 1.0. The next generation goes deeper, literally. Companies are developing implantable sensors smaller than a grain of rice that can be placed under your skin or even inside your bloodstream. These sensors can monitor blood oxygen and carbon dioxide levels continuously, inflammatory markers that spike before you feel sick, hormone fluctuations throughout the day, specific proteins that indicate cancer, heart disease, or infection, and they transmit this data wirelessly to your devices and your healthcare providers in real time. Profusa has developed biosensors that integrate with your body's tissue, measuring oxygen levels for up to 2 years without replacement. Researchers at Stanford have created implantable sensors that can detect early-stage tumor growth by monitoring specific biomarkers. Eversense, now FDA-approved, offers an implantable glucose monitor lasting 180 days with continuous readings transmitted to your smartphone. Now here's where it gets powerful. These sensors don't just collect data. They feed into AI systems that are trained on millions of patient records, looking for patterns humans would never catch. Imagine this scenario. Your wearable notices your heart rate variability has subtly shifted. Your implantable sensor detects a minor increase in inflammatory markers. Your sleep tracker shows slightly disrupted deep sleep cycles. Your smart scale notices a 2-pound increase that's likely fluid retention. Individually, none of these are alarming. You feel completely fine. But an AI trained on data from millions of patients recognizes this exact combination as an early warning sign of heart failure, typically appearing 6 to 18 months before symptoms. Your doctor gets an alert, you get a notification, and intervention happens now, while the problem is tiny. The heart failure you were going to experience next year, it never develops. This is the shift from reactive to predictive medicine. You don't wait until you're sick to see a doctor. The doctor sees you getting sick before you ever feel it. Hospitals are already implementing early versions of this. The Cleveland Clinic uses AI to monitor patients continuously, predicting deterioration hours before it becomes critical. Mount Sinai developed an AI that analyzes electronic health records to predict hospital readmissions and adverse events. Google's DeepMind created a system that predicts acute kidney injury 48 hours before it occurs. But the real transformation happens when this moves into your home. Your bathroom mirror analyzes your skin tone and eye appearance, detecting jaundice or anemia before it's visible to you. Your toilet, yes, your toilet, analyzes waste for biomarkers indicating disease. Your mattress monitors your respiratory patterns, heart function, and movement during sleep. Your entire environment becomes a health monitoring system. All of this data flows into your digital twin. The simulation updates in real time. The predictive accuracy improves constantly. Your doctor doesn't wait for you to schedule an appointment. The system alerts them the moment something needs attention. This is the difference between a photograph and a movie. Current medicine gives you snapshots, occasional glimpses of your health at random moments. Future medicine gives you the full movie, every frame, every change, every trend, and AI watches it 24/7 looking for the plot points that matter. Now let's bring it all together. Continuous monitoring provides the constant data stream. Digital twins simulate that data to predict outcomes. AI surgical systems intervene with superhuman precision when needed. These aren't 3 separate technologies. They're one integrated system. Monitor, predict, prevent, and when necessary, treat with precision never before possible. But before you think this is all inevitable and perfect, we need to talk about reality, because there are significant challenges ahead. I've painted an incredible picture of the future, and I believe this future is coming. But I'd be doing you a disservice if I didn't address the very real obstacles standing in the way. Data privacy and security. Continuous health monitoring means continuous data collection. Every heartbeat, every biomarker, every health secret stored somewhere. Who owns that data? You? The device manufacturer? Your insurance company? And what happens when it gets hacked? Medical data is already the most valuable data on the black market. A breach of your complete health profile could be devastating. We need serious conversations about data ownership, security, and consent before this technology scales. Algorithmic bias. AI systems are trained on data, and if that data reflects historical biases in medicine, which it absolutely does, the AI inherits those biases. Studies have already shown that some medical AI systems perform worse for women and minorities because they were trained primarily on data from white men. If we're not careful, predictive medicine could widen healthcare disparities instead of closing them. Regulatory hurdles. Medical devices and AI systems require approval. That process is slow, for good reason. We're talking about technology that could kill people if it fails. The FDA and other regulatory bodies are still figuring out how to evaluate AI that learns and changes over time. Traditional approval processes weren't designed for systems that update themselves. This means many promising technologies will take years to reach patients. Cost and accessibility. Who gets access first? Historically, breakthrough medical technologies are available to the wealthy long before they reach everyone else. Concierge medicine and luxury health services are already offering early versions of these technologies to those who can pay. If we're not intentional about accessibility, predictive medicine could become another privilege of the few, while the many continue suffering with outdated care. The human element. There's something irreplaceable about human connection in medicine. The doctor who holds your hand when you're scared. The nurse who notices you seem off before any sensor does. The intuition that comes from years of caring for people. As we automate more of medicine, we need to ensure we don't lose the humanity that makes healing possible. I don't share these challenges to be pessimistic. I share them because they're real, and pretending otherwise doesn't help anyone. The technology is coming. The trajectory is clear. But how it comes, who benefits, who's protected, who's left behind, that's still being decided, and that's something all of us have a stake in. Let me leave you with a thought. Right now, somewhere in the world, a doctor is making a diagnosis based on incomplete information. A surgeon is operating with only their natural human abilities. A patient is developing a disease they won't know about for years. That's been the reality of medicine for all of human history. But for the first time ever, we can see a different future. A future where a complete digital copy of your body helps your doctor make perfect treatment decisions. Where surgeons operate with AI-enhanced precision that eliminates human error. Where your body is monitored every second and diseases are caught before they ever take hold. The shift from reactive to predictive medicine isn't just a technological upgrade. It's a fundamental reimagining of what healthcare can be. We've spent thousands of years accepting that sickness is inevitable, that our bodies fail, that medicine is about managing decline. But what if medicine was about optimizing health, preventing problems, extending not just lifespan, but health span, the years you spend feeling truly well? Your grandchildren might grow up in a world where routine illness is rare, where cancer is caught at cell 1, not cell 1 billion, where the leading causes of death today are historical footnotes. That's not fantasy. That's the logical destination of the research happening right now in labs and hospitals around the world. And you're alive at the turning point. The decisions we make today about regulation, about access, about privacy, about investment will determine what that future looks like and who gets to experience it. If this video expanded how you think about the future of health, consider subscribing. I release deep dives into transformative technologies every week. Drop a comment below. Which of these three technologies, digital twins, AI surgery, or continuous monitoring, do you think will have the biggest impact on your life? I read every single comment. And if you want to explore more, I've linked related videos on AI and healthcare and the ethics of medical technology in the description and at the end of this video. The future of medicine is being written right now. The question is whether we're paying attention. I'll see you in the next one.